Welcome back to the shrine. As you can see, the encoder project is still going on. If you haven't seen, scroll back a couple weeks earlier. I was trying to troubleshoot this encoder, which didn't get anywhere. So I decided to go and get a new one. I reached out to the manufacturer, who is Sumtech. They sent me this print. This is for the old one, and the part number is LHE408 and then 1024. This can be different pulses here. You can see I got the 1024. They don't make this anymore, so they sent me a part number for a new one. This is called IRT 320 1024 002. I tried to source this part, and they don't sell it directly in the US. They make it in Japan. Short story long, long story short, I got a eBay seller in China who was listing it for $280 or best offer. I sent him I think a $250 best offer, and then he took it off, jacked up the price overnight to $560, and that was that. So I'm like, he doesn't want to sell it to me, obviously, or he doesn't have stock. So I went ahead and cross-referenced it with DigiKey, and look what showed up. New box from DigiKey, and it's got this Autonix. Okay, so this is called E40H8 1024-6L5. There's a full documentation for this encoder on the DigiKey's website, and in the box, wrapped in foam, is the encoder itself. Ta-da! So, as you can see, there's some hardware here. Looks like these screws, these little screws that fix the shaft, the encoder shaft, to the motor spindle, they came off during the transport. So we're just gonna put it on a magnet here for safekeeping. But here's the encoder. It's got probably a meter of cable attached to it. It's got nice cable here. It looks like 8 pairs plus ground. The black is the ground here, and the part number says E40H8-1024-6-L-5. So looks like we got some documentation here. It comes with a 2-page pamphlet. Okay, this is Chinese, and here's English. So you can see here's the ordering information on this side. So E40S basically means it's a 40mm housing. So there's a shaft type and there's a hollow shaft type, and then the next number, which is in my case H8. Okay, so that's an 8mm shaft diameter, and then we got the pulses per revolution, which is in my case 1024. Some might ask, why is it 1024? It's 2 on the 10th. So there's a 10-bit controller sitting in the CNC and looking for information from this guy. So 2 on the 10th power is 1024. And then the next number is 6. So in my case, you can see it's got A naught, B naught, Z naught channels. That's what 6 means here. And then the next one is L5. So L is line driver output. I looked it up. So here's the old specification. So this one says differential line driver IC. And also if I look back here, This is the original one. This is also says line driver. So I had a little debate about that. That's the type of the output. So the last number is 5. And right here it just says the power supply is 5 volt DC. So this should be a good cross-reference for the Sumtech. And the Sumtech housing, so this is the original one. Okay, so this housing here is 38 millimeter diameter, you can see. So this is the original Sumtech that was put on the CNC, you know, in 1998, 1999, whenever it was built. So it's 38 millimeters, and then this guy is 40 millimeters. But there's plenty of room. You can see that the encoder sits inside here on the motor. The other key dimension was the position of these legs. So if you look at the print, you can see that the spacing is different. So here's a print that shows the spacing, and you can see that the diameter of the pitch circle is 46 millimeters, and the original one is R70. Okay, so this one shows here R70, which doesn't make sense because this is R23 and that's R70. Okay, they are different. So that means I'm gonna have to go and drill some new holes in the spindle motor to properly attach this bracket so that it would prevent movement of the encoder. I'll sort it out. I'll probably make a small fixture to do that. Okay, so here's another picture. You can see the bolt going through here. I still don't know what the radius is. R20? Must be 20. So that would make it 40 millimeter diameter. This is a real bad case of 2. Okay, this is 23. You can see it's a larger diameter, a larger radius. So that must be 20. So that would be a 40 millimeter diameter, and this one is 46. If I want to, I can go and bend these, but I really don't want to do that. So again, this is the new encoder, and you can see the way that the foot is done. It's got this thin stainless steel bracket, and there's one bend here, there's another bend here, a couple more bends. So what all that does, if there is a misalignment between the shaft and you know, the encoder when it's assembled, so there's a gap here. There must be a gap between this inside diameter and the shaft, the motor shaft. So when the motor is spinning, this guy might be wobbling, just as I show, you know, back and forth. But you still need to keep a correct position. So that's why this bracketry is done in such a way. This bracketry is allowed to bend back and forth like this. You know, just think about it, a couple microns or maybe a couple tens of microns. And it still will not fatigue this out, because this is stainless steel. This has real high fatigue cycle. So the first thing I'm going to do is wire it up, hook it up to the oscilloscope, and see if it works. I got it set up with the previous setup. Motor is driving the encoder. Got a breakout box here, and I have a nice clean signal on the oscilloscope. Now one thing is not exactly right. If you look, this is the new instruction manual, and it says viewing from the end clockwise. This should be the signal, okay? And if you look at the old one, it basically says the same. So here's the encoder, and if it's running clockwise, that should be the signal. So if you look here, channel Z is rising, then channel A is rising. Same here, channel Z is rising, channel A is rising. Okay. Now if you look on the oscilloscope, this is channel Z, that's what I'm triggering at, and you can see it's nice and clean and steady. And channel A is actually not rising, but it's dropping. Okay, and channel A0 is rising. So it occurs to me that those channels, the cable markings, are replaced. So if you look here, you can see channel A is black and channel A0 is red. And so I got channel 1 on the oscilloscope hooked up to channel A, and this is hooked up to channel A0. So again, the trouble I see is that when Z is rising, then channel A is dropping. So these two channels seem to be swapped. So I'm going to go and move to channel B and B0. Okay, so channel B is yellow, channel B0 is on a blue channel. So this is channel B, channel B0. And you can see that it's 90 degrees shifted. Okay, so this is where Z is rising. This is where channel this is channel B and B0. You can see there's a 90 degree shift, and this is rising, that's dropping. So channel B is good, but channel A is not. You can see that it's a mirror image. If I would go and swap the leads, that's the picture we should see. So this is supposed to be the picture when Z is rising, then A is rising, and A0 is dropping. But it's not the current pinout. So I don't know. That's the last thing I needed, to have these channels swapped by the factory. I'm gonna go and do a double check, but I'm just gonna go and follow what the oscilloscope is showing me and wire it up that way. I drew another 5-6 diagrams. This is the latest one. It basically cross-references the previous one. This is the pinout for this connector assembly. This was the old one, and you can see the names of the wires, which I had to rename. So now I created a cross-reference for all the channels in plus 5 volt, 0 volt. This is the Autonix, that's the new encoder that I installed, and this is the Sumtag, the old one. So now I created this cross-reference chart, and I also swapped A and A0. So this is 5 volt, the blue is 0 volt, and then this orange, you can see it goes to the yellow channel. That's channel 1 right there. So that is A. This is channel A. And then right out here, green goes to the pink, and pink is channel Z. So I'm triggering on channel 3, which is channel Z. So you can see that channel Z goes up, channel A goes up, and then this is channel B, and it's shifted by 90 degrees and it goes up. So that should be the correct way. So here's the paper document from the new encoder, and you can see when Z goes up here, channel Z goes up, channel A should go up. So that's why I swapped those two. We'll see how it works. So now I can go and let's switch this one to A0. So now you can see Z is triggering, so it goes up. This is A and this is A0. So they are perfectly good, the signal relative to each other. So now I'm gonna go and put this on B0, and this one is, that was easy. So now I'm on B0, and triggering off of Z. So triggering off of Z, This is B. You can see it's shifted 90 degrees and it rises. When Z rises, B is rising, and then B naught is dropping. So that's supposed to be the good order. So now here is the final check. So now I got this one on channel Z, and then this one is channel Z naught. So I'm triggering on channel 3, which is a purple, which is channel Z, and then channel 2 is showing me Z naught. So you can see they perfectly identical and opposite to each other. So that is good too. You can see the wobble I was talking about. But this is not an ideal layout here. You know, hopefully on the motor I'm going to have less run out. I did one more thing. I created a template like this. So what this template is for, you can see the center hole here has an 8mm diameter. So that matches, this is the old Sumtac inverter, or encoder, sorry. So that matches like that. And you can see that the center tab here matches the size. So this is 23mm. I created a drawing here, so this is how it's laid out. So that size is 20mm, and that's a 3mm hole. So what I can do is I can take this guy and crawl up on the top of the CNC mill and basically align this to the shaft, the spindle shaft, push a bolt through here and bolt this down. And then I can come in with my drill, these are 2.5mm holes, and then drill in just with a hand drill into the motor casting. So once that's done, I can tap the holes, and then the new encoder, you can see that matches that bolt pattern. So these are 23mm. I was looking hard on DigiKey, I couldn't find anything that was the same form and size as the original one. So that was something I had to do because I couldn't get the replacement one. So you can see once I drill and tap the holes, I'm gonna have 2 feet here holding this encoder from rotation, and it also has the option for small adjustment. So that is what I'm gonna do now. If you ask me which one is my favorite position, this would be it. Balancing one leg on the ladder and then holding sensitive parts with my other hand, knowing that if they fall from my hand, it's gonna get down there in the chip tray, never be found again. So it looks like that's a good fit. As you can see, I drilled and tapped the holes. So now I'm installing brand new fasteners. So once everything is set up and I confirm that everything works, then I'm gonna come back and put some thread locker on these fasteners. But right now I'm just gonna go and install it as is. The problem is, I don't know what's the zero position for this encoder. So I'm just guessing based on the bolt locations. So I'm just gonna go and tighten these bolts up like so and rotate the spindle by hand and tighten up the second bolt. But you can see it's not an easy place to be at. I agree with you, it's not a crawl space to do some crawl space work. There you go. I can put the cover back like so, and install this cable. As you can see, I've been trying to do everything, tap into this cable and see if it has a proper continuity. So I'll have to remove all this nonsense that I installed. And then this is the fan. I'm not gonna install the fan for the time being. I'm just gonna go and do a test. Well, guess what? It didn't work. It's back on the bench. Here's the manual from Autonix, and I went through the entire English section. So did my wife and my son. We were trying to find something along the lines of index pulse output. You can see here it says index pulse output, so that basically shows the 0 position for the shaft. Found nothing. Went online, downloaded a couple more documents from Autonix. They are in Korea. Couldn't find anything, so I hooked it up, I wired it up. I'm just looking at channel Z, and I'm turning the shaft, and I'm looking at the signal. Okay, and the signal is on auto. It's not on normal or single triggering mode, but it's on auto. And you can see when I turn the shaft, you see it says triggered right there. It changes to triggered, and you can see the blip in the signal. So that is the 0 position. And interestingly, when I turn the shaft, I can feel a little kind of detent. It feels like there's a detent, like a small detent in the shaft. And you can see that if this is the center line here, across the two tabs, the two set screws are 45 degrees apart. That's where it's triggering. Again, you can see the signal there. It changes to touch, triggered, and then the signal changes. So back to the machine. Try it again. The time warp sucked me in. Today is 7-8 weeks later than 20 seconds ago in the video. That video was shot first week of January 2022, and today is February 22nd. Put it together. The new encoder didn't work as anticipated. The spindle orientation did not work, and the CNC speed was about 10% off. So when I was commanding 500 RPM, it was running 450. So I kept going back to it, and it was kind of on a back burner. I was fixing the servo motor, the controller, the amplifier, you name it. And I came back, and you might remember 10 minutes ago in a video I just said this should be the signal for clockwise rotation. So if you look at the encoder here, you're looking from the front, it should rotate clockwise. Well, guess what? I was using this stepper motor, and the encoder was on this side. So if you are connecting the encoder on this side, you can see it will spin counterclockwise. I didn't do anything to this motor. I just turn it on right now to demonstrate that this would turn the encoder counterclockwise. And I had this shaded pole motor laying around, and I thought I'd give it a try. And guess what? It has a 5mm shaft, just like the stepper motor, and I just need to hook it up to power, and it ran. So that's what you see here. But if you look, see I put a tape there, you can see the encoder is turning clockwise, viewing from the front of the encoder, and that's what we got here. Now if you look at the signal, you can see that everything matches. So this is the channel Z. You can see there's channel Z, okay, it rises right here, and then yellow is channel A. You can see channel A rises where channel Z rises, and then this is channel B, and it's 90 degree shifted, and it's rising at 90 degree. So what I did here is I tapped into the A0 channel, so I need to go back and change the A and A0 channels here. So I need to swap them back. I thought that the encoder is not wired internally correct, and it was just my mistake. So the encoder is working. I need to put it back on the CNC and see if it runs. Mr. Golder Intertrade 168 from Malaysia sent a package my way, right here in the center of the cornfield, and it took about 4 days to get here from Malaysia. So let's see what we got inside. Ah, look, it's a new board for my VFD. Supposed to be the same as the original FR A5 AP. That's the name of the VFD. It's a Mitsubishi VFD. So let's open this. Always use the proper tools. There you go. So the baggie has some warnings here. Work on insulated material. Do not work without grounding. Do not directly touch part or pattern. Safe electrically grounded. This workbench is grounded. So all the good stuff. So I'm just gonna handle it at the edges. That's what I've always been doing. So you're not supposed to touch any of these terminals. I looked through this guide. This is the connection to the motherboard or to the VFD, and as you can see, this is basically just a terminal for the encoder. So what we got here is 5 volt. We got system ground, SG system ground, and then we have PA1 and then PA2. We got 2 of them. You can see they are bridged together. So this is channel A, channel A not, channel B not, channel Z, and channel Z not. So I had issues with that guy right there. So this channel Z not wasn't working in my case. So we're gonna go swap it out, see if it works. We are in the belly of the beast, and right here, this is the old board. You can see it's assembled to the VFD. And what I did is I disconnected the 5 volt and the ground, and I'm powering it from the outside with a power supply. And when I'm powering it, you can see this is the yellow lead from the oscilloscope, and the ground is connected to the black wire here. So when I'm probing, you can see the signal going from 0 to 5 volt. So on the oscilloscope, we've got this channel turned on, so you can see it's on 1 volt, and when there's no connection, this comes back down here. So you can see when I turn on, when I connect it, it goes up there. So it's 1, 2, 3, 4, 5 divisions, so that's 5 volts. So 5 volts is going in, and it's powering the encoder now. These are the encoder wires going to the encoder on the motor side. Now we had issues with the channel Z, and I've got my helper here, and he's gonna turn on the drill and spin the spindle. And what we're gonna do is probe into these channels and see how these channels look. So you can see channel A has a nice signal. Okay, so it's rising properly right there. So here's channel B. You can see that has a good signal, and here's channel Z. There's nothing on channel Z. Now if I put on channel Z not, you can see the signal. There's some signal. It's pretty dirty, but at least there's a signal. Now watch what I'm gonna do. So I'm gonna go and disconnect channel Z. Like so. it's disconnected. So I'm gonna go and put the probe on these two. You can see they are the two wires that go to the Z, and now we can turn on the power. So you can see a clear signal on the Z. Now I'm gonna go and just short it to that. So you can see we have clean signal. We have clean signal both on the Z and then the Z naught. And you can see it's opposite. So again, here's A naught, here's B, this is B naught, here's B, this is B naught, and then here is Z naught. You can see signal goes down first, and then this is Z. So we have all the signal. Okay, so I connected the wires back, and you can see we have clear signal there. Here's the old one and a new one side by side. You can see I swapped out the wires, double checked all the connections. So we got 5 volt system ground, A naught twice, then we have B naught, Z and Z naught. So I'm going to take the old one out, put the new one in. Let's do some in situ measurements. So I'm going to do M3 S500. So that will spin the spindle in a clockwise direction. So as you can see, I got the oscilloscope hooked up to the ground lead here. So we're gonna go and tap into channel A. See, we got nice signal. It's got some harmonics, some high frequency harmonics, but nonetheless it's a nice signal. Here's channel B, and then here's channel Z. You can see nice and stable signal. That's what we want. Let's do a final test. I'm gonna load tool number 2, M6T2. Let's hit the green button. You can see the spindle first orients itself. And then it's gonna go deposit the tool which was there and come and load tool number 2. So it seems like it's working properly now. That was a 3-month endeavor with a lot of failures. I'm sorry about this, took so long. You guys had to watch all these videos, but the failures are a part of life. If you never fail, you can't really enjoy success. What I usually say is failure is a feedback. So we got all the feedbacks we wanted. Seems like this is working now properly, so it's time to cut some chips. I hope you guys enjoyed the video. If you did, please give me a thumbs up. And if you like the channel, please don't forget to subscribe. See you next time. Bye.